Very well, I think I'm online. So basically what I will show today is the very first demo of the new version of the EHR server. So if you want to know more about the EHR server, what it is and what it does, you can go to my website, CaboLabs.com, and go to the product section, and you will find information about the EHR server here. You will also find documentation here, and here I will update the guide to the version 1.1. That is the one that I will show you today. So I will update this documentation, but this guide is the full documentation. It has information about how to install the EHR server, how to manage this EHR server, and how to work with the REST API. So all the information is here. Right now, I will share my virtual machine here. So what you are looking at is the EHRServer console that right now is indexing some data that was committed. And here on this console, I have I have run the loader application. That is a small application that creates clinical documents and commits the clinical documents to the EHR server. So right now I'm running the EHR server and the loader application on the same virtual machine. So they're talking to localhost. What I did here is I did a load test. So I created 2,000 EHRs and committed 6 clinical documents to each EHR just for testing how the EHR server worked with all those documents for all those EHRs. And I will show you the application code. So this is open source, so you can use the loader application to load data into the EHR server. It is on my GitHub account. I will show you that account later. But basically, you can just use this application for load testing. So you can create a lot of EHRs and add a lot of clinical documents, and then test how the EHR server work on your hardware, basically, and setting the hardware, like you can add more CPUs, you can add more memory, so you can see if the EHR server works okay on a certain with certain load, with a lot of EHRs, with a lot of clinical documents, and you can find a mix of hardware that works on with your own requirements. Yeah. So if the EHR works okay with your load, it depends really on the hardware a lot. Yeah. If you have a low memory or you have just one CPU, it will perform worse than if you have, I don't know, maybe 8 CPUs and 16 gigabytes of memory. Yeah. So this application, what it does is it creates a client. This is the Groovy client. So I'm programming in Groovy, that is basically Java, a Groovy version of Java, and it compiles to bytecode. So it, at the end of the day, is all jars, yeah, and bytecode. So basically, I'm programming in Groovy, so I'm using the Groovy client. That is another tool that I wrote. It's open source, also you can find that project on my GitHub account. I create a client. I log in with a test user here. I'm on localhost, so I have a test user here, and this login is using the REST API to log in to the EHR server. and that obtains a token, and after that I can work with the REST API because I'm logged in. Yeah. So what I'm creating here is an instance of the loader application. Yeah. And with that, I can do a lot of things. Like I can create a lot of EHRs here. I can create like 2000 EHRs here. Then I have a clinical document that is that contains basic demographic information that is relevant to the clinical side. That is basically the sex of the patient and the date of birth. Because with that we can calculate the age. So sex and age are data that is useful by clinicians, and still the patient is anonymous because we don't have any names or IDs of the patient, so all the data in the EHR server is anonymous. Then I commit some documents to each EHR. So this is committing one document for each of those 2000 EHRs. This is committing two documents to each of those 2000 EHRs. So this line is sending to the EHR server 4,000 documents. Yeah, this is sending 6,000 documents because it's sending 3 documents for each EHR. So this code diagnosis is an encounter document that has a diagnosis that is coded by SNOMED CT, that terminology. The weight control, it commits an encounter that contains information about weight. This is the weight, the height, and the body mass index of the patient. And this medication prescription, I just finished this. I need to test this one, but it creates medication prescription documents and commits those documents to the EHR server. Yeah, and if we go and take a look at the code here, this can also help you to actually see the code that is needed to commit data to the EHR server, so you can create your own commits with your own documents, even reuse some of this code. Yeah. So if I go to, let's say, basic demographic, yeah, what this does, first, it checks that the template, the demographic data, this is in Spanish, but this demographic data template is loaded into the EHR server. The template basically defines the structure of the clinical document. Yeah, that contains, in this case, that is the basic demographic, the date of birth, and the sex of the patient, as I told you before. This loads a clinical document that contains tags in the places that the data will go. And this code basically goes through each EHR on the EHR server. This will take the by 50 EHRs until we reach the whole 2000 EHRs. So this is like a paginated query to the EHR server to get EHRs, and it will go through all the EHRs and then get the next 50 EHRs and then go again. Yeah, and this will change the tags in the clinical document that I loaded here with some random data. So if I go to this method here, you will see that this variable is the clinical document in XML with the tags inside, and these are the tags that are replaced by these values, basically. So on the left are all the tags that are on the XML document, and on the right you can see the actual values. So basically, here there's a gender tag that has a value and a code. So the value is the name of the gender or the sex. So this will be masculine or feminine, and the code will be something defined on the template. Yeah, that is that specifies the clinical document structure, and the date of birth is just a date of birth in a format that is accepted by the EHR server, and the format is an ISO format. Yeah, this is the basic format for a date. So the date of birth will have that format, and also the date of birth is generated. So it's a random date of birth generated, and that date of birth or the age of the patient will be between 18 and 85 years old. So that will generate a date of birth to have, an age between those two values. And that's it. It will just return the clinical document with the values instead of the tags. So that will be a valid clinical document, and that will be committed to the EHR server. So this is the client. This is the commit method of the REST. This will call the REST API, and this will commit to this EHR the clinical document. And also we have some random composer information and a fake client ID. This is the system that loads data into the EHR server, basically. And that's it. I executed that for those 2,000 EHRs. So that created all those documents for all those EHRs. And the EHR server is still working, processing all those commits, because we loaded a lot of clinical documents there. So it's still working and loading data into the database, extracting data from the XML and loading that data into the database, so we can use that data and we can execute some queries. If we use the web console, and we will log in into the web console. This is in Spanish because I will show you some queries that use templates that are on Spanish in Spanish. So here we have the 2,000 EHRs plus 5. Those 5 are the testing EHRs that are automatically created when you start the application on localhost. We have a lot of clinical documents there that were committed by the loader application. This is the size of those documents that in actually on disk. So these kilobytes are like 80 megabytes, something like that. And we have here the templates. We have committed clinical documents for the encounter with the diagnosis, the basic demographic data, the weight control, all those 3 types of clinical documents. And we still need to test the medication prescription template and load documents for that, because I just finished the code to load documents using this template to the EHR server. So I need to test that a little bit. But I will show you some new features we have for querying now that we have some data loaded into the EHR server. So I go to the query section, consultas is queries. I will add a new query. This will be, I want all the EHRs that have the demographic data, it has the sex masculine. So I will composition is clinical documents. So I will query for clinical documents, and I will filter this by basic demographic. And here I select the concept demographic data administrative entry. And here I have two data points that I can select. This is the sex, that is a code text, and the date of birth, that is a date. So I can go and select gender or sex, and that should be equal to masculine, so that those values are defined in the template. And this is what I want. So I will add that that condition to the query, and that's it. I can also add a condition by the date of birth. I can select like masculine and date of birth, or age. Age is greater than 50 years old, something like that. I can do that. But to keep things simple, I will just create this query, and I can test this query also from here. If I run this query here, it will take like forever to execute, because I will go through all the EHRs, but I will select one EHR and I will test if that EHR contains a document that has the masculine gender, and I can see that the result is empty. So I will test with the next one. And there we are. We have one clinical document. So that means that this EHR, EHR 222, this is the ID, the UID of this EHR, belongs to a patient that is masculine, that is a man. Yeah, that will have a result here. So we can use that information for doing interesting things, like crossing this query with another query that, for example, that says that the patient has diabetes. So I can have all the EHRs that belongs to a man that has diabetes. And I also can cross that or refine the demographic query to have also the a range of dates for the age. So or I can say, hey, I want the masculine, and that the age is greater than 50 years old and also has diabetes. So I can query EHRs for that, and that will return all the EHRs that have that information in them. And with that, I can do a lot of things, interesting things. I can create alerts. And when a doctor accesses the EHR of that patient, I can show them that the patient needs some study, for example, or I can do population queries. I can know exactly how many patients comply with those conditions, like masculine, age greater than 50 years old, and has some type of diabetes. So I can do a lot of things with a couple of queries. Yeah. So I will just create this query with just, sex equals masculine. This is a simple one. And now it is slow because I'm working on a virtual machine and the EHRServer is still working, processing those commits. And I will create another query just to show you a new feature that we have that is pretty interesting. I will query for documents that has some kind of diabetes diagnosis on them. So I will query for clinical documents that are compositions. And here I will filter by encounter with diagnosis. Evaluation in the OpenEHR model are things that are records that are objective, that need some kind of validation by a clinician. So we have here the diagnosis archetype, and we have here the name of the diagnosis, and it is coded. So for the code, we can say, hey, the code of this diagnosis is equal to some kind of SNOMED code. Yeah, exactly one code. Or I can say, hey, it should be one of these codes, so we can have a list, and here we can specify 2, 3, 4, whatever. So I will just delete this. Or instead of putting each code here, we have a new operator here, is in SNOMED expression. So we have here we can put a SNOMED expression, and we have here a validator, so we can just check if the SNOMED expression that we added is valid or not. This will take some time. Red is this is not a valid SNOMED expression, or I just copied one of the valid SNOMED expression that I have for testing. So this is green. So this will return. Or what this means is I need all the types of diabetes mellitus. Yeah. So this is diabetes or any subtype of diabetes. So this is a valid expression. Yeah, we already saw that. This was green. And I can add that condition. And this will use a service to process this expression that is very simple, but it's very powerful. It means that I want diabetes mellitus, but also any type or any kind of specific type of diabetes mellitus. So there is a list of codes behind this little expression. Yeah. So we have right now all the power of SNOMED behind EHRServer queries. Yeah. So we have here the expression, and we know that the terminology is SNOMED ID, SNOMED CT, sorry. And we can test this. Let's see if we can, like, I will test this against one EHR, and I will check. So this result is empty. Let's check the second one. Just testing. It seems this doesn't have this diagnosis. Let's see if this is executing correctly. Well, it's difficult to see with all this work happening. Let's see there. There we have the query. There, where are those codes? We have a lot of codes there on the query. Those codes are each one of those types of diabetes mellitus. Yeah, so it seems we don't have here, the queries are being executed, but we don't have diabetes mellitus on these EHRs. Let's continue checking, and there we have 1, 2. On this EHR, we have 2 records, 2 clinical documents that have diabetes mellitus as a diagnosis on them. Yeah, and these, of course, are not the clinical documents themselves. This is an index of the clinical documents. It's just a pointer to the clinical document, and this is the unique identifier of the clinical document. If I want the content of the clinical document, I can query the REST API with this ID, and I will get the content. Also, if I here, I said this is return data, I put yes there. I can execute the query, and I would get the full clinical document here. And here we can look for the problem diagnosis there. And we can look for the name. This is the name of the diagnosis. And this is the a code test. This is the name of the value of the diagnosis. Diabetes mellitus atypic is in English, and this is the SNOMED code. This is a valid SNOMED code. So this was generated by the loadEHR application. Yeah, and this is a valid name for this concept ID. This is a valid SNOMED CT concept ID. And there we have a lot of information that was generated on that clinical document. And here we have the second clinical document, and here's the second diagnosis. That is another type of diabetes. And what we don't have here, at least for now, is a check for the type of diagnosis, a cross check with the gender of the patient. So on this case, we have diabetes mellitus during pregnancy. Yeah, so we need to be sure that will come on a later stage, and that will be an improvement of the loadEHR application, that we double check like this diagnosis should be only for a female, and we should check that the demographic document that contains the sex of the patient uh, complies with the diagnosis that can be only for female, so we don't have a male patient with this type of diagnosis here, but we have a valid diagnosis there, so our query is correct, and we will create this query. So we have created two queries. The first one was a simple one. The second one was using the new feature of supporting SNOMED expressions as query conditions. And there we have all the codes there because we already evaluated the expression. And the expression is this one. And here we have all the codes. And another new feature that we have is the EHR queries. With the EHR queries, we can reuse the logic that we created on clinical document queries, and we can mix them together. So this is where we have a lot of power because we can do a lot of things. I already mentioned that we can create alerts, we can create reminders, we can create analytics, you can create population queries, etc. using this. So the name will be masculine with diabetes, and you know what I will do here. I will select both queries that I have already created, that all the clinical documents that have a masculine on them, and all the clinical documents that have some type of diabetes on them. And what this will do, it will execute both queries, and if both queries return some results, the EHR containing those clinical documents that are on the results of these queries will be returned in the EHR query results. So this means that the EHRs returned by this query, this EHR query, will be EHRs that comply with both conditions, that the patient is masculine and they have other diabetes diagnosis. Yeah, so I can create this EHR query. Yeah, and we can use, I will show you the insomnia risk client test. I will share with you my let me see if I can share my Insomnia REST client window here. So here I have some tests. So I have an endpoint to get the Ehr queries. Let's see if this works. So I have their masculine with diabetes. So this is querying actually the EHRServer they have on the virtual machine. And this is the unique identifier of that query. And I can do two things with this. First, what I can do is use the Ehr Checker. And this is using the REST API. Yeah, this is our new services on the REST API. What this will do is I will send an EHR identifier, and I will send the EHR query unique identifier. That is this one. So we'll execute this query against one EHR, and the result will be true or false. That means that this EHR contains a masculine record with also another record of diabetes for the diagnosis. So if that happens for this EHR, the result will be true. So I will test this, and the result is false because I'm using an EHR that doesn't comply with these two conditions. Yeah. And another, so this is the EHR checker because we are checking some conditions against one EHR. Yeah, and this can be used to show alerts to a clinician when the clinician is actually looking at one specific EHR, and we can use the EHR identifier here. Yeah, but we have another service that it will execute the query against all EHRs on the EHRServer, all the EHRs that you have access to, and it will return the identifiers of those EHRs that comply with all the conditions. Yeah, so we are not passing an EHR ID as parameter, just the query. And I will try to execute this. It might take some time because we have a lot of EHRs and a lot of data, and it was quick. 2 seconds, 2 seconds and a half. Also, we know that the EHRServer is still working, so not all the data is on the database. So I might execute the query again, and I might have another result. So the EHRServer is still working. So these EHRs are the ones that comply with those two conditions. The patient is masculine and they have diabetes as a diagnosis. So I can do a lot of things with this information. Yeah, I have the EHRs of those patients, so I can know what percentage of the patients that I have on my population have those conditions. And I can change those conditions very easily. I can create another query to, instead of diabetes, I can have another type of disease there, or another type of condition. I also can create other queries that can have two conditions. Maybe I want the patients that have diabetes, but also that are obese, so I can use the query for the weight control. So I can create that query here. On the queries, I can do the same. So and I can have different queries for different ranges. Let's say I have overweight, but you can be an overweight patient, but you can be an obese patient, and you can be a morbid obese patient. So it depends on the level of obesity that a patient has. So I can create different queries to check if the body mass index is on certain range. Yeah, so I will create, this is just an example. This is weight control, and I have here the weight, the height, and the body mass index. I will go to the body mass index and look for the data point that actually contains the body mass index. And I can say this is between, I don't know, 25, I don't remember the World Health Organization values for the body mass index, but I think this is considered overweight. This is not obese, but this after this range is obese. So I can create this query with this condition. I will not test this. I will just create this. So I can come back again. I can edit this query. Let's see if this works. And when I edit the query, I can actually select the other condition. So this will be masculine with diabetes and also overweight. And overweight. Yeah, so I can update this. So we have the 3 queries there. I'm not sharing that with, I'm not sharing my screen. What I did is, sorry for that. I basically create another query like I did before. I will show you on the edits. So I basically create a condition over the body mass index that the index is between 25 and 30. I think that is the range for overweight. I just created that. And what I did is I edited the EHR query, and I added the overweight query to the queries of this EHR query. So this will be now, if I execute this EHR query, I will have the masculine with diabetes and overweight, all the 3 document queries will be executed for this EHR query. So this will be the 3 conditions should be met by the EHRs to be on the results. So I will go back to the here we have the service get matching EHRs. I will execute that. So I should have less results. So I found 1. So we can return an alert for this one. We have found 1 patient that is masculine and has diabetes and has overweight. Yeah, and we can have another query that instead of overweight is obese. So the body mass index can be between 30 and 35, something like that. So I might have, if I do that, I might have a different result here, and that patient will be will weight more than this one. So their level of risk for that patient will be bigger than this one to have other complications from diabetes and actually having obesity. And I can also add the condition to for the age. So I can say, and also the patient age is greater than 50 or 60 years old. So if the patient is old, and considering the sex of the patient and considering that they have diabetes and obesity, etc., I can return different kinds of notifications or alerts to the clinician or to the patient itself. Yeah, if we can, for example, we can send specific information to the patient for so they can take better care of their health when they are not sick, and they are not seeing a doctor. We can actually be proactive from the system and send them information about the diseases that they have. So about diabetes, the care that they should um, take, about the food they can eat, about doing if they are obese or they have overweight, about doing some kind of diet and doing exercise, etc., etc., etc. So we can actually send information that is very targeted to the specific conditions of that specific patient. So the information we can send is very personalized, and we just created those queries in seconds. Yeah, so this is the power of having standards behind this, of having OpenEHR, to have all the structure that allows us to actually create the queries, and to have the new support of SNOMED expressions, thanks to our partners BetaTech. They provide the SNOMED expression processor that allow us to integrate SNOMED expression into the EHRServer queries, and those queries are executed over OpenEHR data. So this is the power that we have, and the simplicity. At the end of this, we have EHRs, that very specific EHRs with very specific conditions, and we can make decisions over this very simple result. Yeah, so I can keep executing this, and I might get more results because the EHRServer is still processing data. But that's it. These are two new features that we have. The SNOMED CT expression integrated into the queries, and the EHR queries that actually allow us to combine several queries for clinical documents into one query that returns EHRs that comply with all those conditions. So these are two main features of the new version, the version 1.1 of the EHRServer. And also I show you the loadEHR application that allows us to to create EHRs and create a lot of clinical documents for each EHR. So we have data to actually test the EHRServer with fake data, but that data that makes sense. Yeah, we have date of birth generators, we have diagnosis generators, we have a lot of valid data. For example, what I did is, and this is all in the project. I will show you that in a minute. The loadEHR application has some data there. So we have, for example, some diagnoses, and these diagnoses are valid SNOMED CT concepts. Yeah, so I took these IDs from SNOMED CT. Also, we have, for example, drugs, and this will be integrated into the medication prescription document and document commit. So we have the actual drugs and the correspondent SNOMED CT concept ID. So we have all valid codes there. My plan is later to add more values here. So when we do a random selection, we have more options here. Also to the diagnosis. and we have some random texts here. This is just nonsense text that if you see it, if you overview them, it they seem real, but this is just nonsense. And I use these random texts to fill the text nodes in the clinical documents. Yeah, I hope in the near future to have valid text. I will talk with some EHR providers and some hospitals that have EHRs. So if they can, share some anonymized data with me to have some valid texts to test the EHR server. So we have valid text there. And if you work in an institution or if you are an EHR provider and you want to contribute, you can send me some valid texts, free texts that I can use on the EHR server. And it can be any text like follow up, evolution, etc., some clinical notes, etc. So I can use for testing, and I can improve the loader application. Yeah. So that's it from me, and you can find more information on here on CaboLabs.com under products. You can find more information about the EHR server. Also, you can find on the cloud EHR server website, you can find information about the EHR server itself. We have some guides here and some use cases that are documented here. So you can have more information here. Also, there is an example for clinical decision support, and you have code here that you can test. You have the wearables guide here, so you have a lot of information there. And on my GitHub account, my username is pepasos, yeah, for Pablo Pasos. And you have here the EHR server repository. And also here you can find the loader application. Yeah, you can see all the code is here, and you can build it. I have created builds on Windows because my virtual machine is an old Windows that I have there. But you can easily translate this into shell scripts if you are using Linux or Mac OS. And here also is the EHR server client in Groovy, and the loader application is using the client in Groovy. So you have here also the code, and you have also the build scripts there. Yeah, so you have all the code here, so you can take a look at this and create your own clients or your own applications that create documents and commit them to the EHR server. Yeah. So if you have any questions, please let me know here on the on the on the comments of this video. But also you have on my website, you can use the contact form here. So here we have the contact form here. So you have a way of contacting me directly from CaboLabs.com. If you have any questions, please let me know. I will update the documentation in a couple of days because we did the release yesterday. So we need to update all the websites and the links, etc. Please be patient, but I will do that very soon. Yeah. So if you have any questions or some suggestions or comments, etc., please let me know. Bye bye.